we're going to talk more about scenes. And the reason is beginners coming into Godot are often confused about scenes, and I can see why. The name scene it's a good name, but it's also a name that most people don't have a strong association with, or the only association they have with it is for a play. And you can use that analogy in Godot. We could argue that this scene is, is made up of the pig and some apples here. And if it was a play, the pig could move around in the scene and eat the apples, right? So that's a pretty good analogy. But I've found that it's still a little bit confusing. So scene, the word, was likely used because of a data structure called a scene graph. And you can look up scene graphs, and there's a lot of information about them, but it's a common data structure in vector art programs and also game engines. And a scene graph comes with some different benefits. And we talked a little bit about some of those benefits, right? And some of the relationships between nodes in a previous lecture. But the scene analogy, a scene from a play, kind of falls apart a little bit when we decide to turn our pig into its own scene. And that's what we're going to be doing right now. So let's start by doing that, and I'll give another analogy that I think will help you to understand the concept of scenes better. So let's right click on our pig here, and we're going to do save branch as scene. So what that's going to do is it's going to take the pig and all of the nodes that are children or grandchildren to this pig, and it's going to save it as another scene. Because currently we only have this one scene, the world scene. But then we'll have two scenes. We'll have a pig scene and a world scene. Let's right click, save branch as scene. There we go. It's going to want us to save it. And it'll be called pig.tscn. That's good. Save. And it will then hide the children that were associated with this pig, right? We can't see those anymore over here in our scene. And it will add this little button right here. We can click on this, open an editor, and this will open up the pig scene inside of its own little tab up here. So now we can see our two scenes. And now when we're inside the pig scene, we can see the other children that were associated with this pig. Now the first thing we're going to want to do is take our pig, and we're going to want to reset its origin back up here to the origin. So come to transform, set the X to 0 and the Y to 0, and save. Now, if we come back into our world here, you can see that it's been reset in here as well. And we probably don't want our pig over there, so we'll move it back down here. But when we move the pig in the world scene, we're updating this version of the pig so that its position is down here inside of the world. Basically, where is the pig relative to the world node, right? However, if we're over here, it won't set us back down here because this is the pig relative to itself, right? This is the root node of this scene, so that doesn't move it. Okay? So now if we run the game, everything will actually still work the same. Still works exactly how it did before. Although we've still got 300 for our speed. Probably not going to like that. If we come into our pig scene, we can hit this little refresh, and that will set it to 50. And if we come back into world, it will be set to 50 as well. Okay, so let's talk about scenes, right? One of the benefits of a scene graph data structure is that when you move the base or the root of the scene, that movement or that action that you perform on the base is applied to all of the children. And why is that useful? Well, obviously, if we want to move our pig, we want the sprite and collision to move with it, right? I'm going to Control Z to undo that. We want the sprite and collision to move with the pig. And so that makes a lot of sense. That's because let's take our scene analogy and let's go back to our node analogy. Remember, earlier I was explaining that nodes are like the different elements of a table. You've got the wood, you've got the screws, and those different, you've got the legs, the tabletop and the legs, and then the screws to hold those together. You've got all of those different elements, and you use them to build a table, right? So if the legs, the wood of the tabletop, the wood of the legs, the steel and the screw, if those are each nodes, and you use all of those nodes to make one scene, which is your table, if you pick up your table and move it, you want all of those things that are a part of that table that make up that table to come with it, right? You want them all to move with it. And so if you think of a node as like a base building block in the real world, wood or metal or whatever it is, think of a scene as an object in the world, something that we give a name to it, right? So if you have a chair, that chair is going to be made up of different things. If you move it around, everything that makes up that chair will move with it. If you have a car, everything that's attached to that car will move with it. Now, this gets even better in Godot because you can, let's say you're working on a large team with a lot of other developers. You can assign one person to make a chair scene and another person to make a table scene, right? Those scenes will be independent of each other. And then you can assign another person to make a house scene, okay? So somebody will make a base house scene, somebody will make a chair and table scene. Well, you can put that chair and that table scene inside the house. In the same way that we have our world right here and we've stuck our pig scene inside of this world, we've put the pig inside of the world scene. You could create a house scene and then put a table and chair, each their own scenes, inside of that house. Then if you move the house, the table and chair would move with it. You could then take that house and put it inside of a city scene. And so you can use scenes to build more complex other scenes, right? And you, as a designer and developer, you get to decide what you want to be its own scene and what you don't want to be its own scene, right? You could make a car scene and you could have the wheels be just a bunch of nodes put together to make a wheel. Or you could choose to make each wheel its own scene as well. You could make a wheel scene and attach that to the car scene. You get to choose how you organize it like that. And I do recommend, and it's going to be based on what's useful to you, right? In this example, in this case, for example, our pig, it's useful for our pig to be its own scene because it's got its own sprite and it's going to be accessing its own, or it's got its own script and it's going to be accessing its own sprite and its own collisions and stuff like this. It's useful for us to have this as its own scene. It makes sense to have the pig as its own scene and then just stick that pig inside of the world. Let's get rid of our pig inside of our world scene. So click on the world scene, click on pig, and delete it. Now the reason I want to do this is simply I want to show you guys how to instance a scene that you've created inside of another scene. And there's two ways to do this. One is to come down into your resources, click on the pig scene, and drag and drop it into this scene. And we'll have to move it because it reset to the center there. There's one way. That's the way that I usually use, to be honest. Or you can click on world and you can click this little button right here. It's next to the plus one. That will bring up a child scene we can instance. We'll select pig. And now our pig is inside of our world scene. So you'll want to organize your game with lots of different scenes and and those scenes will be built up of nodes, and that will create a complicated but decoupled game, because ideally each of your scenes will be able to run by themselves. And I'll show you how to run a scene. If we click on the pig and we press this run button up here, this pig should be able to run in itself, not outside of the world, independent of the world. And if you're able to make all of your scenes run using this button right here without any errors or any issues down here, independent of any other thing, then your game is going to have pretty low coupling, and that's a good general rule of thumb to say that your game will be able to scale well. You'll be able to make a very large game without running into tons of bugs every time you change something. Now we're going to animate our pig, and so it's useful for it to be its own scene, because now we're going to add its own animation player. So we'll add a new node, an animation player, just like we had before. We'll come into our script, and we'll want to get access to this animation player. OnReady var animation player equals animation player. So we're getting access to it. Now we're going to want to create an animation. To click on the animation player, come down to animation, we'll create a new one, we'll call it idle. And this animation honestly doesn't need to be very big. What we'll do for this is click on the sprite, and then we'll come to animation, and then we'll key our frame at 0. Great. Okay, you can see it added a new frame. We'll just go back to 0. And now our idle animation will just be the pig standing there like this. Perfect. Now we'll click animation again. We'll add another animation. This animation will be called run. And for this animation, we're going to have, we'll cut the animation size down to 3. Whoops. 0.3 actually. Technically, we could set idle to 0.1. It doesn't really matter, but it might be more consistent. So come to run, come to the very first frame, and we're gonna key this frame for the first frame. We'll key this one, create, and then we'll want to move forward one step, and we'll want to move forward a frame. So we'll want to zoom in here. This isn't very easy to see, so let's zoom in right about here. Okay, so you can see we've got 1. These are different snap positions because we're 0.1 snap. So switch to this 0.1, which will be the next frame. Switch to frame 2 and key that. And then we're already on frame 3 now, and we'll want to switch back to the very first key, or the very first frame, and we'll key that. Now what it should look like is jump, land, stand. Okay? Jump, land, stand. We want this animation to loop, so we'll click this right here. This will make it loop. We also want our idle animation to, well, I don't think it matters if our idle animation loops or not, but we'll just set it to loop anyways. And if we run this animation, you can see the pig animating, moving around. And now that we've created these animations, and that's pretty quick, we'll just come into our code here, and we'll need to be able to update these animations. So when our pig is moving, we're going to play an animation. Animation player.play run. Now let's run this and see how this works. You can see that we can now run and that animation plays. we're going to want to update our characters, the direction the character is facing as well. And we'll want to create a moving variable. There's other ways to do this, but this should be pretty simple. Var moving equals false. So create a variable called moving, set it to false. And then down here, when we're moving, we'll say moving equals true. And then up here, we'll say moving equals false. And then we'll get rid of this. I'm just going to do Control X. So now what's happening? Every single frame at the very start of our frame, we say moving equals false. But then if we start moving, it will set moving to true because it runs this function, sets moving to true. So at the end here, we can detect whether or not our pig is moving. So we can say if moving equals true, animation player.play run, else animation player.play idle. There we go. Let's run our game and see how this looks. And there we go. When we're moving, the animation looks a little bit quick to me. The character animation plays quickly. If we come into our animation player, we can, there's a couple things we could do here. We could change the length of the animation, or we can change the playback options and set the speed to 0.5. Either of those should work pretty well. There we go. The final thing we'll do is we'll want to update the pig so that it faces the proper direction. And we can do that. If you look at sprite, our sprite node, we have a property under offset called flip horizontally. And you can see if your sprite is centered like that, then this will flip nicely. Well, actually, I don't think it matters if it's centered, if I remember. But this property, you can see whenever we click on it, we get set flip H down here. So that gives us a pretty good hint as to what the property is called in code. But to be sure, we'll look it up. So search the help, sprite. It's always good to get used to using the help. And you can see right here, we've got flip H is a Boolean, so it will be set either to true or to false. Flip underscore H. This is a property that is associated with sprite. So if we come into our pig here, when we're moving to the right, we'll say, we'll need to get access to our sprite, right? Because if you try and do flip H equals true here, or false here, like this isn't going to work. It says identifier flip H is not declared in the current scope. Basically what it's telling us is area 2D doesn't have this property. What are you doing? Well, of course area 2D doesn't have the property, but our sprite does. So we'll get access to the sprite node, and then we'll say sprite dot flip H equals false, and sprite dot flip H equals true. So when we're moving left, we set it to true. When we're moving right, we set it to false. And there you go. Our little pig is moving around on the screen. That's going to be it for this lecture. Thank you all so much for watching, and I will see you in the next one.